So we know that that's length times by width, 9 times 9. Which is?
81.
So now we can work out, what else is it made up of? I'll get a different colour pen so we can see. It's actually made up of 1, 2, 3, 4 triangles. Yeah? So we know the formula for working out a triangle. Base times height. We've already mentioned it a little bit earlier on. So we've got 9 times 13 divided by 2. Let's get the calculator and work that one out.
58.5. Yeah.
But there are 4 of them. So we're going to times that by 4, which gives us
234.
dead. Yeah?
Yeah.
So now, that's the base, 81. That's the triangles, 234. We add those two together, which gives us 315 square metres. Yeah, it's going to be. So in effect, really, when it asks you to work out areas of nets, it's quite easy because the shapes are relatively straightforward shapes. Yeah, they're relatively straightforward shapes. I'm not sure if the answer's on here. Let's have a look at this. 315. Yeah. Let's do the prism. Let's do the prism. Okay. So again, we've got to have a net of the prism. So there's the base of the prism, the bottom of it. Okay, it's like a Toblerone. We've got a triangle at this end. We've got a triangle at this end. Those two are going to fall up. And then we've got 2 rectangles. Okay, so there's the prism. We've got 15 centimetres. We've got 5 centimetres. I'll show you all these in a second. We've got the height of this. I'll draw it kind of like here. It's 4. I think that's all the information we need. Apart from the width of the bottom, which is 6 centimetres. Yeah? So we've got all the information we need there. Let's do it then. Let's do the bottom bit first. Let this bit here in red. Length 15, width 6, yeah? Because it's a rectangle, so 15 times 6. Let's do these rectangles because there's 2 of them, they're going to be the same. That one and that one, the 2 blue rectangles. So it's 15 times 5. $75. There's 2 of them, so that's another 75. And then we come to the triangles. So I think these are a little bit easier to work out because once you see it split open like this, you can see what the shapes are. So we know the formula for the triangle. It's the base times the height divided by 2. The base is 6. The height is 4. 6 times 4 divided by 2. So 6 4s 24 divided by 2, 12. That's one of them. There's another one. There it is. And then we just add those together. We just add those numbers together to give us the area of that particular shape. Let's have a look what it's going to be. It's going to be 14. 9, 10, 11, 12. My brain's gone.
264. That's what I've got. Yeah.
264. 264. Yeah? Let's see if we're right. So again, no need to be worried about these when you see them. 264. Easy peasy, yeah? So, they're not too difficult. Break it down and you can see instantly what shapes you've got, whether it's a pyramid, whether it's a prism, whether it's a cuboid or a cylinder. You can see. And I think it makes it fairly easy to work out surface areas. Okay? The other thing we need to think about, the other thing we need to look at, and it's all to do with shapes and it's all to do with this kind of topic that we're talking about now, are what's called plans and elevations. Okay? And a lot of people get a bit mixed up about plans and elevations. Plans are when you look down on something from above. Elevations is when you stood in front of something and you look at it. So if we are stood looking at the front of this house, we're stood looking at the front elevation. If we were flying over it in an aeroplane and we were looking down on it, we would see the plan. Okay? That's basically what we're going to be looking at. So there we are, looking at the elevation. When you stood in front of the house, like this chap is here, you can tell how high it is, you can tell how wide it is, but you can't tell how far back that house goes. You don't know how deep it is. Okay? And that's the front elevation, or the front view. If we stand here at the side, like this chap is here now, we can see how tall it is, and we can see how deep it is, because we could see how far back that house goes now. But we don't know how wide it actually is, because we're only looking at the side of the house. Okay? And that's what you've got to be able to picture if you see one of these that says draw a front elevation, draw the side elevation, or which is the side, which is the front, which is the plan, etc, etc. Yeah? There you are, flying over the top of it. If you imagine flying over the top of the house, you can see how wide it is and how long it is, because it will just look like a rectangle or a square, but you can't tell how high it is. Yeah? How many times when you've flown over things and you've thought, oh, I wonder how tall that building is? You can't tell. It just looks like a box on the floor. And that's the plan. That's the plan. So what we've got to be able to do, what you've got to be able to recognise, is shapes like this. Okay? What's the plan? What's the front? What's the side? Okay, what would that look like as a front? What would it look like as the plan? What would it look like as a side elevation? So we're not going to do the partners with the blocks bit. I'm just going to rub it off on this board. So luckily for us on this picture, the colours have been broken down into yellow, purple, pink and blue. So if we're looking at the front of this block, what can we see? 1, 2, 3 blocks. 1, 2, 3. We don't know how far back they are, but when we look at it from here, I can see 3 there. I can also see 1 here. Now it's 2 blocks back that, but I can't tell if it's 2 blocks back because it just looks like it's there. Does that make sense? Yeah? Because that's all I can see. That's the front. If I look at it from the side, I can see that it's 1, 2, 3, 4, 5 wide. 1, 2, 3, 4, 5. They're the blue ones. There's 1 there, but it's on the top of the 1, 2, 3rd block in. Yeah, that's that one. If I'm looking down on the top of it from the plan, 1, 2, 3, 4, 5. Excuse my drawing. I'm looking down it. Then it's 1 in and 1, 2, 3. And then it's 1 stuck on there, which is this one. That one's irrelevant because we don't know how high that one is. Yeah? So that's what the plan would look like. Does it make sense, that? Yeah? Does it make sense? So what you would get in an exam question, you would get a little picture like this, for example. The front elevation and the side elevation of a cuboid are drawn on the grid below. So there's the front, there's the side. What you've got to now draw is the plan. Imagine you're flying over the top of it. Okay? Imagine you're flying over the top of it. Let me just get a prop. So here's my box. It's a cuboid. There's the front. There's the side. Okay, the question is, draw that bit on the top. So basically what we're going to do, we're going to pick up this box, because what we can see how long it is, and even when we look at the plan, we can still see how long it is. And there's the side. So when I do this, to make this into a plan, I can see how long it is, and I can see how wide it is. I can't see how high it is, because that's the height. So remember, when you've got a plan, you can see the length of it, you can see the width of it, but you can't see the height of it. Yeah? You don't know that that box is 3 squares high. When I do that, you don't know that it's 3 squares high. You can see that it's that many squares long, 1, 2, 3, 4, 5, 6, and you can see that it's 1, 2, 3, 4 wide. But you can't see how high it is. Does that make sense? Yeah? Does that make sense? It'll look like that. Okay? That's how it would look. And it doesn't matter what kind of shape you get. If you get that shape, it's the same kind of thing. They've added a little bit extra in here. It's an exam style question. They've added a little bit extra in. It says draw the front elevation of the prism on the grid, that grid there, using the scale of 1 to 3. So basically, we're making that 3 times smaller. Yeah, 3 times smaller. So I'm going to do the drawing. You're going to tell me what to draw. Some of them numbers we don't need. Okay, well, one of them we don't particularly need. So we're going to stand here and we're looking at this particular shape there, because that's the front elevation, remember, that's the side of it. So we're looking here. We'll start with the bottom. How many squares on this grid do I have to draw on the bottom? So it's 18 centimetres, the scale's 1 to 3, we're shrinking it.
6.
6.
Yeah, 6, yeah.
1, 2, 3, 4, 5, 6. There's the bottom done, yeah? Let's come up this side. 15.
So it'll be 5?
1, 2, 3, 4, 5. We divided it by 3. So that one's that one done. I think we need to go across the top now. 10.5 divided by 3.
Oh gosh. 3.5?
1, 2, 3.5.
Oh, no.
No?
Yeah.
3.5.
3.5.
Yeah, well done.
That's that one done. We've only got 2 numbers left. Which one do we need?
Do we need the 4.5?
Yes, we need the 4.5, because that's a 7.5. When you look at something from the front, you don't know how deep it is. 4.5 divided by 3 is
1.5.
1.5. All you do now, just draw the line, and that's it. That's it. So, a combination there of knowing a little bit of scale, but recognising what's the front, what's the side, what don't I need? I don't need the 7.5 because I don't know how far back that's going. That's a 3-dimensional picture, that's a 2-dimensional picture. And we're looking at this. We're not looking at that. We're just looking at that. Yeah? Does that make sense? Good stuff. So you don't need to do this. You don't need to make that into a three-dimensional. That's as it is. That stays exactly as it, because you're just looking at the front. Okay, so far so good. Right, let's look at some angles now. I'll just stop it because it's a different thing.